Hello everyone. In this video, we will discuss the various test signals which are used in signal system. In the topic of signal system, the impulse signal and the step signal are the best test signals to test any system. Besides the impulse signal and the step signal, there are two more signals which are used to test a system. These are the ramp signal and the parabolic signal. The characteristics of these test signals is that they undergo sudden shock, sudden change, or having a constant velocity and constant acceleration. These are the four characteristics of these test signals. So we will discuss all the test signals in this class. Now, from the definition of impulse signal, we have seen that an impulse signal is a signal which has a value 1 at t equal to 0 and its value is 0 when t is not equal to 0. The impulse signal is denoted by the letter delta t, and del of t is nothing but it is an impulse at t equal to 0 with amplitude is equal to 1 at t equal to 0. So the value of delta t will be equal to 1 for t equal to 0 and delta t will be equal to 0 for t not equal to 0. We can represent it graphically as shown in this figure. Here we see that the value of this impulse is 1 at t equal to 0 and the value of delta t is 0 when t is greater than 0, when t is less than 0. Its value exists only at t is equal to 0. This is the diagrammatic representation of an impulse signal. The next test signal is the step signal, which is denoted by the symbol u of t. The value of u of t will be equal to a for t greater than equal to 0 and u of t is 0 for t less than 0. Here a is the amplitude of the step. However, if the value of the amplitude is 1, then in that case we will call this signal as unit step signal and the value of a will be equal to 1 in that case. This is the diagrammatic representation of a unit step signal. We find from this figure that the value of ut is a for all t greater than equal to 0 and the value of ut is 0 for t less than 0. The third type of signal is the ramp signal, which is denoted by the symbol r of t. Now r of t will be equal to a of t, at when t is greater than equal to 0 and it will be equal to 0 for t less than 0. However, if the value of the amplitude a is 1, then this will be called a unit ramp signal, and this is the diagrammatic representation of a ramp signal. We find that the value of RT increases linearly with respect to time and it is 0 for t less than 0. The fourth type of signal is the parabolic signal, which is denoted by the letter Pt, and the value of P2 will be equal to at square by 2 for t greater than equal to 0 and the value of Pt will be 0 for t less than 0. However, if the value of a is 1, then it is called a unit parabolic signal. If we plot the graph of this parabolic signal, we will get the parabola as shown in the figure. So we find here that the value of Pt is at square by 2 For t greater than equal to 0 and for t less than 0, the value of pt will be equal to 0. Now we will find the S domain representation of these test signals. These are the time domain representation of the test signals. If we take the Laplace transform of the impulse signal, it will be equal to 1, as we have already seen in the chapter on Laplace transform. So in S domain, this test signal will be represented by 1, that is Laplace transform of delta t will be equal to 1, that is in S domain the value of the impulse will be equal to 1. Similarly, ut will be represented in S domain as a by s if its amplitude is a. However, if the value of amplitude is 1, then the Laplace transform of the unit step signal will be equal to 1 by s, which we have already studied in the chapter on Laplace transform. Similarly, we have also seen that the Laplace transform of RT, that is ramp signal, will be equal to a by s square. However, if the value of a is 1, then this will be known as unit ramp, and the Laplace transform of unit ramp function will be equal to 1 by s square. Similarly, we can find out that in S domain, the pt will be represented by a by s cube. However, if the value of this amplitude is 1, that is if the value of the a is 1, then in S domain the unit parabolic symbol will be represented by 1 by s cube. Now let us find out the relationship between these various test signals. That is, we will find out the relationship between all the 4 types of test signals. Now we see in this figure that the value of delta t is 1. So we take the integration of 1, that will be equal to ut. It means that integration of delta t will be equal to ut, because integration of 1 is ut. Or we can write this as d by dt of ut is equal to delta t. Similarly, if we take the integration of ut, it will be equal to r of t, because integration of 1 will be equal to t and integration of a is equal to a into t. So d by dt of rt will be equal to ut. In this way, we can find out the relationship between the unit step function and ramp function. Similarly, if we take the integral of rt, it will be equal to pt. Pt is the parabolic function, or we can write that d by dt of pt is equal to r of t. We can also express any test signal in terms of the other test signals. Suppose we have to express the impulse signal in terms of the ramp signal, then we know that delta t is d by dt of ut, and we also know that ut is d by dt of rt. So on substituting these values, we find that delta t is equal to d square by dt square of rt, that is delta t is equal to d square by dt square of r of t. Similarly, we can find out the relationship between the other test signals by substituting the values accordingly. Thus, we find that these are the various test signals which are used in signal system. We found out the time domain representation of these signals. We also found out the S domain representation of these test signals, and the relationship between all these 4 test signals can also be found out with the help of these relationships. I hope this topic is clear to all of you.